Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. Ladies and gentlemen, let's continue our tutorials about early analysis program. Hopefully, we have done a lot of work. We have defined many things, and this is the last tutorial. We're gonna talk about the definition of the building, and we're gonna generate the energy analysis report. By the way, this day, it is not a special, it's not a regular day, it is a very special day. It is the December 24th, it is the night of the Christmas. Happy New Year and Merry Christmas. Feeling excited also because I'm preparing for my thesis defense. So, feeling excited, and I hope the next year becomes a better year, and I hope you got the knowledge in the HVAC career as I wanted or as I recommended. So we're gonna celebrate with each other after the finishing the tutorial. This Christmas, not a regular day or normal day. So let's now talk about what we have done. We have, through the project, we defined the weather, and here for simulation, as for the energy analysis and the spaces, and we have here the schedules, the FT schedule and the fractional and the utility. Okay, and we talked about the assignments and the design tab for the cooling or heating loads, and the other tabs for the energy analysis. And then we define the walls, the roofs, the windows, doors, shades, chillers, cooling towers, the boilers, and the electric rates and the fuel rates. Hopefully, all we talked about the definition of defining the internal loads and general information about the zones, walls, windows, doors, and so on. Okay, and then for the systems, here we talked about the many types of systems and the air system type and system components here, and the zone components, and also many things. We covered all these things and the sizing data. And for the equipment, for the energy analysis, you have to check out this tab for energy analysis. According to the equipment type and their system type, the equipment will be changed. So you have to fill these things, okay, for the energy analysis. And also we talked about the plans for the chiller plans, generic, anything that is related to the only cooling and heating loads, they must be generic. If you wanna take into consideration the energy analysis, this from chiller plant up to remote source steam. And here our chiller plant, if you wanna define the chiller plant, and here through the hot water plant for energy analysis. Okay, now we're gonna talk about the building for the energy analysis. And here, first of all, we have here the plants, systems, miscellaneous energy meters. So on the plants, if you have plants in your building, like we have here all the plants that were defined, but we only need to choose the plants that is related to the energy analysis. So do not check on the generic. Okay, so we have here chiller plant and hot water plant, and automatically they will be added with the systems. Okay, of them automatically, but to make it easier for this chiller plant, here look at this system. Okay, one. Okay, I'm not gonna make this. Suppose that we only have one system. Okay, it's only one system, and here are the plans. Okay, so the system is a chilled water air handling units, and central heating is gonna be hot water. Okay, so if it is hot water, I'm gonna go to the building, chiller plant, hot water plant. We have here this. Okay, and for the plants systems, now we can edit. Why? Because this system will use hot water, okay, not natural gas or these things. And click OK. Also, here systems, hot water, configuration, of equipment. We have here the boiler, and the boiler will run here electric resistance or natural gas or fuel oil or propane to heat the water. Okay, so here you have to choose the method of heating the water. Okay, so it may be natural gas. So go to plants and boiler report. Okay, also the chiller. You have to check out many details. Okay, you have to be ready. And do not define anything that you do not need. So here are the buildings, new default building. We're gonna choose chiller plant for the cold water or chilled water or the hot water plant. And here we have only one system, and you can multiply it if you have many other systems, but as the same as this system. So the miscellaneous energy here is the first important thing you have here to get the name. If you have any miscellaneous energy in the system that does not relate to the HVAC system, suppose that in the spaces we have here the office. Okay, here are the internal loads, but the cooling and heating loads, I only here define the heat gain or the heat loss or these things. Okay, the heat gain to this zone. Okay, from the overlighting and task lighting, electrical equipment, and if really miscellaneous loads. But here I only care about the heat gain. I do not care about the electric load. Okay, so for the same zone, we have here electrical equipment that give heat or supply heat to generate heat inside the zone. This electrical equipment runs run on maybe run on the electricity, so we have to define the electric consumption. Also, if we have gas boilers or these things that run on natural gas or any kind of fuel, we have to determine these things in the miscellaneous energy to be added to the cost. Okay, here are the systems, miscellaneous energy. So here the name, suppose that this is the electrical equipment Okay, and so here defines whether this item qualifies as a process or regulated load. Okay, so here we have from this tree, the process is an optional input that defines whether the item qualifies and process energy for purposes of a lead energy and atmosphere credit one analysis. So if it is a process energy use, place a check in the box, otherwise leave the box blank. If you are not performing a lead analysis, then this item is not relevant and it can be left blank. So if you wanna make lead analysis, so you have to check this thing. So please, before I forget, if you have here some planned systems that do not need plans, suppose it's a DX system, you can find it here and you can add it. Okay, it will not be added automatically. Okay, where here is system tab. Okay, so we have here for the DX system. Systems which are not associated with a chilled water or hot water or steam plants must be directly specified on this tab. In the figure above, HU4 and the HU5 use DX cooling equipment and were directly specified on this tab. Okay? Okay. So now we have miscellaneous. So here is the electric or natural gas, fuel oil, propane, remote hot water or remote steam. You have to define the electrical equipment and the lighting also. You have to set the PQs of the consumption in kilowatts. Okay, just a tutorial, so I'm gonna make these random numbers. Also here the schedule is gonna be fraction schedule. Okay, if you have different schedules, you have to check it all, select them, and if there's the electrical equipment follow the lighting and the people, you can use it. Okay, so you can edit what you want. Okay, so now the electrical equipment or lighting have different peak. You can use it also for natural gas, for boiler will be natural gas. Okay, and you have to set the MBH value, and also you have to get the schedule. Okay, and so on. You have to make these things and complete it. So here this is the name, and here the PQs, maximum energy of fuel rate as the item. For this item, schedule defines the fractional. Please, you can check this out for more information. Okay. After finishing this, here the meters. Here is the rule of the rates. So the electric, if you can define a new electric rate, or you can just use what we have defined. For natural gas, simple fuel, and for the fuel oil, if you have fuel oil in this and you can create a new for the fuel oil, can use what you want. Okay. Also, the average building power factor, this item defines the average building power factor used to convert electric power data from units of kilowatt to kVA. It is only applicable when the electric rate chosen for the building uses units of kVA or for demand rated charges. If units of kVA are not used, the power factor is not relevant, so the value can be left at 100%. Further details: when entering electric rate data, the user has to have the option of defining demand-related charges in terms of working power measured in kilowatt or apparent power measured in kVA. So when the kVA option is used, the program computes a simple estimate of building kVA each hour by dividing kilowatt power data by the average building power factor. So the power factor is the average ratio of working power divided by the apparent power for the building. This is very important. You have to understand how the calculations are calculated, or how the data results are calculated. Here the source, electric and generating efficiency. So this item defines the average generating efficiency for the electric power plants that provide energy to the building. Okay, so this is the source, electric and generating efficiency. This value is used to calculate source energy totals on the two energy budget reports. Okay, we're gonna talk about the budget report the next couple of minutes. So this input is only required if the program will be used to generate the energy budget reports, and local energy codes require that both site and source energy totals be provided. If this feature is not needed, set the efficiency to be 100%. So energy budget report generated by a HAP list the site and source energy for use for a building. Site energy is the actual energy consumed by equipment in the building. Source energy is an estimate of the energy required to generate electricity provided to the building. The difference between site and source energy quantities is due to inefficiencies in generating electricity and transmitting it to the building site. When this is required by energy codes, the codes usually mandate the efficiency value to be used. It typically varies between 25% and 33%. For fuels and non-electric energy sources, site and source energy values are equal since the fuel is consumed at the building site. Okay, so I have to know this. Also, the additional floor area. This item defines non-conditioned floor area in the building not already accounted for. Okay, if you did not account this area before, so you have to do it here. This input is used together with the conditioned floor area to calculate cost per square feet, cost per or square meter, energy per square feet, energy per square meter. Check figures on the building simulation reports. In certain cases, local energy codes may require these things. Okay, so you can please check out this information also. So gentlemen, after finishing this, you can click OK. Now we have here the sample building and it's not simulated. So we can generate the report, but before generating the report of the building, we can generate the report of the system. We generated already the report of this thing. Okay, May to September. This is for the cooling and heating loads. It's not simulated, not sized. So now it is sized but not simulated. So print view simulation results. Okay. So we have here overview about the system simulation report. System simulation reports contain load and equipment performance data produced by the hour-by-hour simulation of system operation for 1 year. This information is useful for learning about equipment operation and also when investigating energy consumption patterns. HAP offers 5 different system simulation reports, 3 of which can be generated in tabular, graphical, or text file format. The latter is used for exporting data to external programs such as spreadsheets. Okay, so note that simulation reports are only available in the full edition of HAP and not in HAP system design notes. So using various menu options, we have here table, graph, text. If you want these things, check on it, check on them. And here we have monthly simulation results, daily simulation results, hourly simulation results, unmet loads report, zone temperature report. Okay, and here's for July is the daily simulation results, and here are the hourly simulation results from. You have to determine these things, but you have to know that it takes a very long time according to the period. Okay, so from January the 1st to December 31st, it took 6 hours to generate this report. Okay, so please be careful. Okay, and if the text here, it will be added to the project location, and here if we make it okay, so the text only notice what is going on. Okay, and here are the tables, so it's according to this. Note, gentlemen, that if we have here this system, here's CAV zone, make it VAV chilled water. Okay, FT available. Okay, so we have to sorry, to define it again. We're CAV single zone or VAV or whatever, and here we have these things, and here the general cooling from May. Sorry, the cooling. We have to turn off these things. Okay, here the general heating. Okay, zone, whatever. Okay, not sized again. So size not simulated. First of all, you will not be able to use the graph. Okay, I heard the text. Okay, no problem. And so select up to 3. If we do not have here graph specifications, why it only used when these graph options are only available when a single system has been selected and that system was previously simulated. So this is the first time we simulate this building. So your warning, you requested the tabular version of the RNA simulation results report for a period longer than 5 days. It may take a long time, okay? Also, the TXT version will be added to the project in the C drive, okay? Okay, the next version of the more reports has been selected. The report will be written to TXT files, and this is the location. Okay, So I have here the report. So here are the monthly simulation results from May to September, and here of the lighting and electric equipment, central heating, central cooling. Okay, notice. And here are the total. And here are the daily simulation results. So from day one, daily system results for July. I think it's because it's the peak. Everything you need is here, and table 1 airline system donation results for Sunday, January 1. This is the according to the day that we have defined in the weather simulation tab. And here are the RC air system simulation results for Monday, January 2. And okay, I'm sorry, this Sunday is not according to the simulation tab. I'm sorry, it's according to the current settings. We defined the report to begin from January 1 up to here January 2 and January 3, January 4. The details that you need January 5 and January 6. Okay, then no need to see anything. So now data shown here for unmet load. This report for diagnostic purposes only. Varies represent total unmet hours for each cooling and or heating unit. I'm gonna show you these things. This only if we have the X cooling or the X heating. Okay. So let's go to the system and suppose it is package rooftop unit. From January 1 to January 6. Just wait, please. January 4, 5, 6. So here is the air simulation. Okay. And the system simulation results. Here's the total electric equipment kilowatt hour. And here is central cooling coil load at each day of July, central cooling equipment load, central unit CLG input, heating, and so on. And here are the results for July day, and the results for Sunday. This is based on the input January 1 hourly, January 2. Everything is gentlemen, you will find it here. And Tuesday, January 3. Okay. So I think results for Wednesday. HAP knows these days according to the simulation tab in the weather. Okay. And here, January 6th, Friday. Okay, here in the unmet load report. So that's one report for diagnostic purposes only. Values represent total unmet hours for each cooling and heating unit. Notice that equipment air capacity is sufficient. Here is the number of hours that the equipment capacity is sufficient to give you the required load, and capacity insufficient by 0 to 5%. Here is 2 hours in June. Okay, only 2 hours. The equipment will not be able to give you the load. And here capacity for 5 to 10%, 3 hours, and here is 1 hour. Okay, the total hour is 6 hours, and here the total hours with equipment loads. Okay, also here the zone temperature statistics. So for the monthly simulation results, report contains monthly and annual totals of load air energy consumption of the system. Okay, and the daily reports contains daily totals of loads of energy consumption for months for the system. The month is selected by the user. Okay, and the hourly simulation report contains the hourly profiles of loads and energy consumption for the system for a series of consecutive days selected by the user. The unmet loads, gentlemen, here is number of hours during which the equipment has sufficient capacity to meet the cooling or heating load. Insufficient numbers of hours during the equipment capacity is efficient by 0 to 5%, and this is for the DX systems. Okay, for example, the coil is 100 mph, but the equipment capacity only is 97 mph. It is insufficient by 33%. 3%. Therefore, an hour is created. Okay, created to the 0% to 5% column in the table. Okay, and so on. So for the DX fan coil and WSHP systems, the statistics are summed for each fan coil or WSHP unit in the system. So therefore, if the system has 25 fan coil units and each is deficient capacity by 5 to 9% for a single hour, 25 hours will be added to this column, one for each fan coil that is deficient. Because of this, operating hours and unmet load hours are much larger number for fan coil and WSHP systems than for the general systems. Okay, for example, a packaged rooftop system may show 3,000 hours of DX cooling operation. A DX fan coil system with 25 zones might show 75,000 hours of DX cooling operation, 3,000 hours multiplied by 25 fan coils. So and so on, gentlemen. Please, you have to take a look on this information to know what's going on and these details. Okay, also, so the zone temperature here we have occupied, and unoccupied. What is this? Maximum zone temp and hours more than 5 above throat range. So maximum zone temperature. What is this? So the warmest temperature occurring in the zone during hours in the occupied period. Okay. Also, please check out if you want to take care of the LEED EA credit one summary report and these things. Okay. So hours greater than 5 F above throttling range. Number of hours during which the zone air temperature was more than 5 Fahrenheit, 2.8 Kelvin above the upper limit of the cooling thermostat. Hours 1 to 5 above throttling range. Number of the hours during which the zone of air temperature was 1 to 5, 0.6 to 2.8 Kelvin above the upper limit of the cooling thermostat. But the HAP uses a tolerance of 1 F before counting hours above the cooling throttling range. And then the cooling set point plus throat range here throttling range. The upper limit for the cooling thermostat defined at the set point plus the throttling range. Hours within throttling range or dead band, the number of hours during which the zone air temperature was between the upper cooling limit and the lower heating limit. So this is the number of hours the zone temperature is in the required comfort range. Okay. Note that these hours also include times in the 1F 0.6 Kelvin tolerance margin above the cooling limit and below the heating limit. Heating set point plus throttling range. The lower limit for the heating thermostat defined as the heating set point minus the throttling range. Also the hours 1 to 5F below throttling range, number of hours during which zone air temperature is 1 to 5F, 0.6 to 2.8 Kelvin below the lower limit of the heating thermostat. So note that HAP uses tolerance, okay. Hours greater than 5 Fahrenheit below throttling range, number of hours during which the zone air temperature is more than 5 Fahrenheit below the lower limit for the heating thermostat. Also, minimum zone temperature, the coldest temperature occurring in the zone during hours in the occupied period. Okay, so this is the occupied things we have here for unoccupied conditions. Here, unoccupied, the maximum zone temperature, the warmest temperature occurring in the zone during hours in the unoccupied period. Cooling set point plus throttling range, the upper limit for the cooling thermostat defined as the set point plus the throttling range. The heating set point minus throttling range, the lower limit for the heating thermostat defined as the set point minus the throttling range. Also, the minimum zone temperature, the coldest temperature occurring in the zone during hours in the unoccupied period. So, I think it's a lot of information. So you only have to know the importance of each tab and what is the procedure that you have to follow to make it through the acceptable range. So this is for the you can get this from your senior engineer, and you're gonna learn these things by practice. Okay. Also, you have to check out this information for more details. Okay. So now we have just finished the system report for the energy analysis. Close it. Okay, sized and simulated. Now we're going to talk about the plants. We talked about the heating and cooling loads or for the plants, the previous tutorials. Now it's the time for the energy analysis. But for the systems, you have simulated this. Also, you can find here the graph specifications. Here are the graphs. You can select the external cooling coil load. Okay. You'll find these things in the directory. Okay, so here are the graphs also for the central cooling coil load, central heating, and here for day of month, the central cooling equipment load, central cooling coil load, here central cooling equipment. Okay. Okay, central cooling. Of course, these things, according to the type of the system. Kilowatt hour, kilowatt hour, watt hour. You cannot select different units. Also according to the period. Okay, everything in January here. So the graphs. Okay, so here the day of the month and kilowatt hour. Okay, for July. And so on everything in details. So here the chiller plant, we have created these things. Okay, and for this we have here the monthly, daily, hourly, and the unmet, but for the plant. Okay, so here's the plant simulation result from January according to January, and here, okay, monthly simulation, and here the daily simulation, and here the hourly simulation, May 1, May 1, May 2, okay, May 3, and so on, and also the unmet load report for chiller plant. So here the chiller plant, okay, oh, okay, and there is no systems. Why? Why? Because it's packaged. So here, from May to September, okay, and the daily simulation results for May, and the hourly, and May 2, May 3, May the 3rd, May the 4th, and everything. Okay, details and the consumption. Kilowatt, consumption in kilowatt input, and chiller output. Okay, so after finishing it, thus also you can get these graphs. Okay, so this is the simulation. You from these things you can know the details of the chiller output, plant cooling load, cooling coil load, and primary water pump or condenser, and these things. To know if you have an unacceptable limit or unacceptable results, so you have to read the calculations again, and you have to reach the point that you can say it's okay for the plant, it's okay for the system. Okay, also for more information you can click F1. Also for the hot water, So this is for the hot plant simulations for the hot water, and these things, heating coil and HW storage tank losses, and these things that we talked about. And here the boiler input gas, the boiler output. You have to check out every number, and if it is not acceptable, you have to the calculations again. We have here the boiler miscellaneous electric kilowatt hour, primary water, this pump, and here the for May, and boiler miscellaneous electric kilowatt hour, okay, and primary water, and so on for Friday. And here the unmet heating load. Okay, there is no insufficient hours. Can make it here, can get what you want in graphs. You cannot, I think that you cannot choose kilowatt hour. Okay, you have the same units. Oh, I'm sorry. I have here these things. Graph, graph, graph. Okay, so find the year monthly simulation results for hot water plant of this month and KBTU. And here also heating coil load, HW storage, plant heating load, and so on. So gentlemen, here for the monthly, daily, hourly simulation results for plants, you can check out anything you don't understand, the cooling coil load, the total chilled water cooling coil load for the air system served by the plant, the engine fuel input, chiller miscellaneous, chiller miscellaneous electric, anything you will find in the report that you do not understand. Of course, we're gonna take many hours to cover these things for the tutorial, so I suggest you have to read these things by yourself, and you have to practice and ask about many things and to know how to get the information. Okay, so plant cooling coil load, your total cooling load for the plant is the summation of cooling coil load, pipe heat gain, and the chilled water pump heat gain. Okay, so we covered these things, and here just the final report, and you have to check out everything. Do not generate the report and submit it just for fun. This is the very complex process to check out every word and every input and output. Okay, so also if you have here, okay, cancel. So gentlemen, these reports for the simulation reports is only for the electricity, electric consumption, or the gas or fuel consumption. Does not relate to the for the cooling and heating loads. Only print review design results, not simulation results. So the simulation results give you the reports for the energy Okay, so kilowatt hour or pressure thermal unit, and not in tons or in kilowatt like the generic. Okay, if here the generic, if you make simulation review, errors will be found, of course. Why? Because it's generic chilled water. This is not, we cannot give the energy simulations. So generally, these reports for the simulation reports, it will contain the loads, okay, the cooling coil load or the heating coil load, and the consumption for electric consumption or the fuel consumption for the system or for the plant, like this plant cooling coil load. Okay, it will, you will see it, and these things, the input kilowatt hour, energy. Please, you have to be careful when you deal with the units to know what's going on. It's very pretty important, okay, to know if this is for electric consumption or fuel consumption, or this is the heating or the cooling load. Okay, now we can go to the building and see what's going on. So gentlemen, for the building, again, here are the plants and the systems and the miscellaneous energy. Here are the additional sources, the non-HVAC systems, like the lighting, the natural gas or the fuel, or also for the elevators, any kind of source of the energy, and you did not define it anywhere elsewhere, you have to define it here for the electrical equipment consumption, the lighting, the fuel source. Okay, so this is the non-HVAC systems. You have to get the peak. Okay, so again, please, this is very important. The miscellaneous energy tab contains information about non-HVAC systems in the building that have not already been accounted for. This is optional information. Whether miscellaneous energy use needs to be defined depends on the scope of your in-general study. The application section below discuss, okay, the further in details, and we talked about this. Okay, so we'll click cancel. Now not simulated. So print view simulation results. So about building simulation reports, building simulation reports contain energy consumption and energy cost that are produced by the building energy simulation. These reports can be used to compare energy use and energy costs for alternate designs, each represented by a separate building case, or to investigate energy use patterns for an individual building case. HAP offers 14 different building simulation reports. Note that simulation reports are only available in the full edition of HAP and not in HAP system design loads. Using various menu options and toolbars buttons here, can find comparative reports, annual cost summary, annual energy and emissions summary, and here are the summary reports. You can check on anything you need, and here are the detailed reports if you wanna get them, and here are the billing details. So contains here options for two reports which allow cost and energy results for groups of buildings be compared side by side on the same report. Summary reports contain annual cost and energy use data for individual building cases. The detailed reports contain tables of monthly energy and cost data for a single building case. So detailed reports for the single building case. The section also contains a billing details report which documents the calculation of the utility bill for each energy type of fuel source. These reports are useful when investigating energy use patterns for building or validating utility bill results. So here also you can use profiles contains hour by hour energy use profile for building for one energy source or fuel type. Separate reports can be generated for each energy source or fuel type. Further, separate tabular, graphical, and so on. You know that you can get them. Also, for the LEED report, we're gonna talk about this. So here you can get these things. Can make this the building details electric. It provides electric from to from okay to, as you know, can make it and just preview. So here, gentlemen, the air system. So here the annual cost for the electric consumption and lights, electric equipment, cooling and heating in dollars, and miscellaneous electric, and miscellaneous fuel zero. So here the grand total. Okay. Also the annual cost per unit floor area for the HVAC systems, non-HVAC. Also the component cost as a percentage of the total cost. And component here for the HVAC components, non-HVAC. Also here's the electric. And annual energy consumption also for the sample building. Okay, and here are the totals. Here are the details of the consumption, and if we have CO2 equivalent, we'll get it. This is the emissions summary. This for the green buildings. You can use these things for the green buildings, and also here these things for HVAC and non-HVAC. And of course here we have the cooling and miscellaneous electric equipment. This is the consumption of electricity, and here are the numbers in details. HVAC and non-HVAC per floor, not per floor. Okay. So the target of this report to know what's going on inside the building for HVAC and non-HVAC, anything, any source, fuel or electricity, to know how to make savings. Okay, not just to get the report, know how to make savings for this building without affecting the human comfort. Find here energy budget by energy source, building simulation reports. Okay, so generating these things. So I find here the energy budget by the system, component report list the annual energy consumption itemized by system components such as fans, cooling, heating, and these things, and annual coil loads, energy consumption by system components. You can check out this information, and here the energy budget by energy type. According to the type, you will find these things and monthly component. So you can, you can check these things by yourself. You have to learn how to get the information. So here we have the energy budget by energy source. Okay, here are the sources of these things, non-HVAC, the sources. Okay, and here are the monthly cost for cooling, heating, lights. Notice that the heating is very small, and the cooling, especially in the summer. Okay, you have to be careful when you look at this data and analyze it. So HVAC component costs and non-HVAC miscellaneous in dollars. Okay, here are the costs also. Here are the details, monthly energy used by component. Okay, everything, every single thing, you will find it here. monthly energy used by energy type, demand energy. Okay, we talked about this. Customer charges, if you and your taxes, total charges, billing demands. We before generating the report, we selected the details was gonna be are gonna be electric. So you can make this natural gas or anything or fuel oil. Okay, so you'll get the details of this the other options. The maximum demands, the time of maximum demands. Here, notice the dates: off peak, normal peak, overall. We talked about these things. And here are the hours. Okay, and here the usage for the graph electric use profiles. We talked about the profiles, and you can generate for electricity or fuel oil or any other option or another fuel source. Notice, gentlemen, the important thing here is the total. Okay, this is the total cost for this penalty. Any other schedule will talk about or show the details in each month, in each day, in each hour, so you can know what's going on and what savings can be achieved by the detailed analysis. But here is the annual cost. Okay, so here is the grand total. Notice that the heating here is $2,018 for the heating. Okay, it's not too much. Why? Because we use natural gas or hot water. So what if we make this boiler? So this is the beauty of this program, is what if questions. Go to systems, heating, general heating. Notice that we have here heating source hot water. Okay, but we're gonna heat this water by using electric resistance. For the building here, open. Okay, just to update it. Print simulation. Okay, okay. Take the chalk. Wait for the chalk. So the boiler now will use electric resistance, not natural gas or fuel. Notice that the heating, oh my god. So here is the beauty of these things. Notice that the heating cost increased. Notice, oh my god, 54.6%. So here boiler also here steam or hot water. I'm gonna make it hot water. According to these things, these are the details that will determine the cost. Okay, and print. Okay, so here, okay, that's why we use, so recommended for these projects to use not use electric resistance. Very consumes high energy. Okay, so now we can talk about the LEED. So before here, duplicate a building with spaces and HVAC equipment like this. Find duplicate building with spaces and HVAC equipment. What is this? So if you wanna make analysis for LEED, energy and atmosphere credit 1 or LEED, or and atmosphere these things, whole building energy simulation option, it is sometimes necessary to make a copy of a HAP building and all the air systems, plant spaces and so on that are linked to the building. An example is after a proposed design has been created and you wish to make a copy of all its data as the basis for assembling the baseline 0-degree building. So the duplicate building with the spaces and HVAC equipment option is used for this purpose. Okay, so you can select it and you can find here LEED baseline building B000. Okay, when will appear the creating baseline building or proposed design. If you choose baseline building like this, so here duplicate items will be identified as LEED baseline building or proposed baseline building. The program will use the prefix B30 and the name of each entity, system, plant. Okay, it copies so you can easily identify the data. If you choose proposed design, the program will use the prefix P and the name of each entity copies. After making your selection, click OK to duplicate the building. Program will then make a copy of the original building and all spaces. Okay, and these things linked to the building. Names of copied items will be assigned the proper prefix described above. Okay, so when the program is finished, the message will be so suppose that is this line. Following building is plans and towers successfully duplicated. Okay, B. Here we find here these things. Okay, and your systems. Okay, and your our systems. Okay, so now suppose that we wanna perform LEED. Let's click F1. So when performing an analysis for LEED, energy and atmosphere credit 1 or LEED, then energy or atmosphere requisite. Here, whole building energy simulation option, it is necessary to make 4 copies of the baseline building. Okay. The first baseline building using an orientation equal to the proposed design is assembled by manually defining the characteristics of its spaces, systems, plants, chillers, cooling towers, and boilers as necessary. It is necessary to make 3 further copies of the baseline building with spaces rotated 90 degrees and these things, respectively from the original baseline building orientation. The perform LEED 90.1 PRM. This option is used to quickly generate these 3 copies of the baseline building. To use this option, select the building category, okay, and we can make it. So 3 copies will be of the building and spaces and equipment created in these copy spaces will be rotated. So we're gonna make it for one time. Okay, so assemble building copies. Okay, so we have here the sample and the other things. Okay, so here the building designation, gonna make perform LEED, no, LEED to 009, generate LEED. Okay, uncheck this, can check this. So designation for LEED report proposed, where the proposed the sample building baseline. So we do not find the other buildings also. So here's the standard. Okay, we can make this frame view results, LEED generate, and we'll find these things. Okay, so the sample buildings, and here where is the have to be 0. Will it be 0? Okay, I think I Okay, let's do it again. This is the proposed building. Okay, and not simulated. I changed this to save our time. Okay, now I wanna perform LEED. Okay, so we have here 90 and 180 and 270. You'll find the proposed building and B000. So this is the base building. So we have here the three exactly like this. There is no baseline 0 degrees, and here is the proposed design, and here is the LEED. Okay. Simulation results for the LEED. Okay. I'll click preview. One more proposal baseline building designation for the LEED. Credit summary report. And this is none. This is allowed, but please make sure it's intended. Okay. I don't wanna get the 0. Like okay, so we're gonna be over 60. So now we're gonna know which orientation is the best, and also we can generate B000 as a baseline building. Also we can compare between two buildings. Okay, so please have patience. Here are the air system simulations. And here are the annual cost summary report to compare the annual energy cost results for the buildings and energy emissions. We talked about this, but we're gonna now see the differences between the buildings. Okay. So here is credit, the building, the floor, rating designations, baseline performance, performance rating methods, baseline energy costs, contains energy cost information for the 4 baseline buildings, and the baseline average found, section 1.8. Okay. So in this table, each row contains data for one energy or fuel source. So gentlemen, we have here many things, and here the discussion, you can check it out. Just a comparison between the buildings. So here we have a proposed building, and the proposed building be A on 80, and here the proposed building, this is the first building, of course, and we know that this is our first number. So it's second, third. Notice that the proposed building is the best for the heating, and it's not the best for the cooling. Okay, so the best for no, here is the best for the cooling. So you have to check out the total: 680, 685, 681, 68. So the proposed building is very good as annual cost, also per floor area. Okay, and many things, and here the emissions summary, grand total, and here the component, the proposed 2365 is okay, 2365, HVAC or non-HVAC. These things, the proposed building. Okay, notice that there are differences between the values. So here the B090, 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 and here is B090, B090. Okay, the details of B090. Now here B180, another report. Okay, so and so on. Can get the details of all buildings, and you have to know what is the source that affects your system badly, and you have to eliminate it and decrease that source, so and so on. Okay, so you can get a very good comparison between the 3 or the 4 buildings. Also, you can here post buildings, duplicate building spaces as 000. Okay, find here all of them. Also, for this 000, you have to, you may compare it on this 000 here. Find. Okay, can click on this. Here I do not want to LEED. I only want to compare between them. Yes. So finally, you can duplicate this building with get any copy of all the plans, zones, and systems, and you can change. Look here, the 000 and the proposed building. Notice that they are identical. Why? There is no changes. There are no changes. Okay, because it is the same copy. So you may change some things, something that you do not see that it is acceptable for you, and make it in make the modifications in the B000. Okay, and then you can compare between the all buildings, okay, and the LEED. Here is B000, and here we'll find for the proposed building, and so on. Okay, ladies and gentlemen, I think that I have just finished this long tutorial. I'm sorry. We have here, we got to the end, our end point. Feel glad, very glad to reach this amazing point. We have generated all kind of reports, and we have just seen how to affect your building, how to see the savings, whether spaces, systems, plants, buildings, and the project libraries, from schedules up to fuel rates. And here the final thing is your building, all of them are simulated. Thank you very much. It's a very good end for me, at least, and we have covered many things, but you have to be professional and read the information. Please use the manual to get what you want. Use Google, use websites to get books like this website. You can get any book, Shri fundamentals, or the HVAC and fundamentals. Okay, H fundamentals or HVAC fundamentals. Also back systems, ASHRI, period time simulation, HVAC or pumping design, well pumps and these things. Okay, as you know. So if you wanna any other thing, please contact me under the video or by emails. I appreciate your questions. I'm glad to connect with you. Okay, thank you very much, and we have to finish this tutorial with Merry Christmas, guys. It's Merry Christmas. Sorry, here. It's Merry Christmas, Jesus Christ. Christians think that he was born on 24th of December, I think, of the night. Thank you very much, gentlemen. The next tutorial, we're going to talk about the wizards and how to use the wizard. Okay, for the quick use all the of this very good or excellent program. Merry Christmas and Happy New Year. And thank you very much. Vielen Dank. And благодаря. Спасибо. Wassalamu alaikum wa rahmatullahi ta'ala wa barakatuh.